Hello, everyone. Welcome back to the Apex Science Academy. This is the physics problem for week 5. So this problem is asking you to use qualitatively reasoning to find the center mass of complex objects such as human body. So in this problem, it's important as noted in the problem. We're not trying to find exact center of mass. We're trying to find approximate. And center of mass is the point at which you can assume all the mass is going to be focused on. Well, in reality, they don't, right? However, because the rest of the body is moving with the center of mass, so you can always assuming that the gravity is acting at the center of mass. And for many people who are doing sports, and you always hear the idea of where should you put your center of mass. Or in fencing, you should put your center of mass as low as possible so you're more stable. And for for gymnasts, the center of mass is important, but you're doing all this kind of all the tricks, backflip, forward flips. So the center of mass is a really important concept, and here we're trying to do it in a quantitative, intuitive way. Okay, so here is a person sitting on a chair, and what I'm doing here is I'm using 9 points to represent the parts of body, and I have 1 mass point to represent the head, and I have 2 points, 2 mass points to represent the upper body. And I have 2 points to represent the left and right arms. I have 2 points to represent the upper part of the legs, left and right legs. And I have 2 points to represent the lower parts of the legs, again, left and right. And this is, again, approximation, but you probably wanted to have each mass point represent the same amount of mass. So that's how we divide the human full body into 9 parts. Well, okay, so on the right, I removed the picture so you can see the location for each mass points. And the blue diamond shows the center of mass of the 9 points, which is the average position of 9 points. Accurately, you can do this by find the coordinates for each of the points and find the average of those 9 numbers. Average of 9 numbers for X position and an average for 9 numbers for the Y position as well. But again, this is a qualitative problem, so you can eyeball it where the center mass should be for these 9 points here. And it's roughly speaking on just above the chair. So over here, this is the point where the center mass is. And again, that agree with what your expectation is, right? The chair is supporting the body mass, right, by providing a force that we're going to talk about during the courses. Okay, so next one. So this is a gymnast position, right? Again, I have used 9 mass points to represent the 9 equal masses that are how I divide the whole human body. On the right is where I place the 9 mass points are. See the head, right? The head, 2 arms, 4 points for the legs, and 2 points for the upper half of the body. And again, the center mass is roughly over here. And it's something around the wrist area, right? That's for gymnast. This is where the center mass is. And next, this is a fencing position, right? So again, I'm using 9 points, 1 for head, 2 for the arms, 2 for the body, and 4 for the legs. The center of mass is right in the middle around the wrist area. Okay, again, this is an approximation. If you want to do it precisely, you would find the coordinates for each of the dots and you calculate the average. But this is good enough for us for qualitative reasoning. So, okay, so that's it. Hopefully, you get an idea of how to find a center of mass by dividing the complex object into approximately equal masses and using 1 point to represent each mass. And so this is how you could do it. And in fact, this is how video games are actually designed. They use a finite number of points represents each part of the body or each part of the monster in that case, and they do physics based on that. Okay, so I think this is all for it. We'll be talking about this during the courses more, but hopefully this gives you a flavor of how the center of mass is represented. Or the more important concept is what is a mass point in physics. Okay, thank you, and see you next week.